Welcome to the DIY Honda Garage channel. The DTC P0325-17 and P0328 refer to a malfunction in the knock sensor circuit, indicating high voltage. The knock sensor is a device located typically on the engine block or cylinder head, playing a critical role in detecting engine vibrations and knocking. It sends a voltage signal to the Powertrain Control Module, PCM, and if this signal exceeds a predetermined threshold, it signifies an issue, prompting the PCM to store the DTC. Proper functioning of the knock sensor is essential for optimal engine performance and preventing potential engine damage due to knocking. This diagnostic trouble code requires careful troubleshooting of the sensor itself and its associated circuits to identify the root cause of the high voltage reading, as outlined in the provided manual. The DTC P0325-17 and P0328 indicate issues with the knock sensor, which is responsible for detecting vibrations caused by engine knocking. This component relays information through a voltage signal to the PCM, allowing the vehicle's computer to adjust engine timing for optimal performance. The knock sensor is typically mounted on the engine block or cylinder head, allowing it to accurately sense vibrations. If the sensor's output voltage exceeds a defined limit, this indicates a fault in the system, prompting the PCM to trigger the corresponding diagnostic trouble code. The purpose of the PCM is to safeguard the engine's performance and prevent damage that may result from knocking, illustrating the critical role of the knock sensor in maintaining overall engine integrity. Several factors can cause the DTC P0325-17 and P0328. A faulty knock sensor may produce an abnormal voltage signal, leading to these error codes. Additionally, an open circuit in the wiring connecting the sensor to the PCM can interrupt the signal, causing excessive voltage readings. These codes could also suggest a malfunction within the PCM itself, which may misinterpret the sensor's output. Poor grounding conditions can add resistance, skewing the sensor readings and falsely triggering a high voltage condition. Lastly, external interference or damaged components in the surrounding circuitry could lead to abnormal voltage readings, underscoring the importance of a thorough inspection of related components. When the DTC P0325-17 or P0328 is triggered, a driver may notice various symptoms indicating an engine issue. The check engine light will typically illuminate on the dashboard, signifying a fault detected by the vehicle's onboard systems. Drivers may also experience diminished engine performance, including reduced power or responsiveness. A knocking noise may become audible, which is a direct result of detonation or improper combustion due to incorrect timing adjustments. Other symptoms may include a noticeable drop in fuel efficiency as the engine struggles to compensate for the abnormal conditions. In severe cases, prolonged exposure to these symptoms could lead to significant engine damage, making it vital to address the underlying issues promptly. To begin troubleshooting DTC P0325-17, the first step involves turning the vehicle on to access the necessary diagnostic information. Once in the on mode, you should check the voltage output from the knock sensor. This is typically accomplished by disconnecting the knock sensor connector and using a multimeter to measure the output voltage. A normal reading should be around 5.0 volts. If the voltage reading falls within the expected range, the issue likely resides within the knock sensor. However, if the reading is abnormal, you may then need to explore other components in the circuit for underlying issues. Addressing this initial check is crucial in isolating the cause of the high voltage condition. The next step in troubleshooting DTC P0325-17 involves inspecting the wiring circuit associated with the knock sensor. Before proceeding, ensure to disconnect the PCM connector to avoid any electrical interference while testing. The inspection requires checking for open wires in the knock sensor circuit by thoroughly assessing the female terminals of both the knock sensor and the PCM. A multimeter is used to test for a resistance of less than 1 ohm. This indicates that the circuit is intact. If the resistance measures higher than 1 ohm, or there are indications of a break in the wire, this would confirm that there's a problem within the circuit itself, necessitating further repairs to restore proper function. In the final step for DTC P0325-17, if previous testing reveals that the knock sensor and associated wiring circuits are in good condition, the next logical step is to inspect the PCN itself. To perform this inspection, you must first ensure that all connections are secure. Then, test the PCM functionality to verify that it can correctly interpret signals from the knock sensor. This might involve checking the PCM for any visible damage or errors in its programming. Additionally, ensure to assess if the PCM responds correctly to inputs under normal operational conditions. If the PCM fails to meet standard performance criteria, it is likely the source of the issue, and it may need replacing or reprogramming. After completing the troubleshooting steps for DTC P0325-17 and performing necessary repairs, it is critical to verify that all work was effective. First, clear any stored diagnostic trouble codes using the proper diagnostic tool. Following this, conduct a test drive of the vehicle to ensure that no further issues occur and to monitor the system's behavior under typical operating conditions. Pay attention to any return of symptoms, such as check engine lights or performance problems. This step is crucial for confirming that the repairs have resolved the underlying issues and that the vehicle is functioning correctly. Proper verification ensures long-term reliability and performance, crucial for driver safety. In conclusion, troubleshooting DTC P0325-17 involves a methodical approach to identify the root cause of a high-voltage condition in the knock sensor circuit. By following the systematic diagnostic steps, including checking the voltage output of the sensor, inspecting the wiring circuits, and evaluating the PCM's functionality, technicians can effectively pinpoint the issue. Each step is designed to ensure that all potential problems are addressed thoroughly to prevent engine performance issues and damage. Correct identification and repair of faults not only enhance vehicle reliability, but also prolong the life of the engine. Always remember that effective diagnostics are essential in maintaining vehicle safety and performance. Please like and subscribe to the channel. See you next time.